Okay, looks like we're up and running. This is just going to be a completion of the worksheet. It's time just to get some skills more developed and maybe chat a little bit more deeply about occasional question here or there. But let's have at it. All right, so 16, number 1, write this subtraction statement as a product. Okay, and I'm hoping that folks saw the difference. 2 squares, 4x squared plus 9y squared times 4x squared minus 9y squared. But I expected you to be able to do that. The question is, did you spot another difference of 2 squares? The skill's only good if you recognize things. So keeping your eyes open, hopefully you cannot factor. There's that word again, factor. You cannot write that as a product. Sum of 2 squares cannot be written as a product. You can try. Good luck. But we've got a 2x plus 3y and a 2x minus 3y. And that's that problem. All right, number 2. 27 minus 64. Hoping that you're getting more familiar with those perfect cubes. So 27 minus 64, we work with the cube roots, which in this case are 3 minus 4. That's not going to be hard to work with. And then we build off these 2 numbers now. Build what's in this parentheses. So I hope you're taking the time to actually master this so you don't have to look at it in a perplexing way the rest of the term. To get 27, I got to get 9, which is 3 squared. The product, 3 times minus 4 is minus 12. We just have to change the sign of that product. And we square the last term, which is always going to be positive. And it looks like we got 21, 31, 37, negative 37. Geez, let's see. What is 64 minus 27? Ooh, that's 37. Wow, so 27 minus 64 must have a sign change. Looks like it's right. And so that's a useful skill, changing sums and differences into products. All right, and then the next question is, it's very similar. 27x to the 6th plus 125 to the 3. Y to the 3, 125 y cubed. We're going to work with the cube roots. Well, 27 we know is 3. X to the 6th is x squared times x squared times x squared. Yep, that's a 3-dimensional shape. Perfect cube, yeah, perfect cube. Boom, 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 x squared and x squared and x squared. So it looks like we're going to pick x squared. And 125y to the 3rd, 5y. And now we're going to build that second parentheses off of these numbers. So we've got 1x squared. We need x squared times x squared here. So we need the 9 to get to the 27, and we need x to the 4th. Those 2 multiplications. And now we've got to multiply. We got 15x squared y. So it's minus 15x squared y. Squaring the last term, 25y squared. You multiply this out and you get a cancellation of 4 terms. We'll just look at 2 of them right here. That's 45 x 4y. There's got to be a minus 45 x 4y. Let's see if you can spot it. Gee, I think it's right here. I think 3 times minus 15 is minus 45, and x squared times x squared is x to the 4th, and we got a y. Yeah, so there's another cancellation of 2 terms in there. You can go look for it. All right, it's that problem. And I feel a little scrimmage coming on, a little test coming on very soon. Maybe even I'll announce it today and give you a little assessment tomorrow. So 22x to the 9th, 2x to the 9th, minus 6x to the 5th. Well, that could be done as 2 times x, 4, 5, 6, 7, 8, 9, minus 2 times 3 times 1, 2, 3, 4, 5. Right? And I hope in your pre-algebra, AB plus AC, you knew that you could, or you know that you can take out an A and create that as a product, right? And that's what we're doing here. And that's the first rule of writing products. Take out what's common. I see a 2. I see a 2. We'll take a 2 out. I see 5 of them. I see 5 of them. We'll take that out. And now we'll have to take out the, oh, what's left? Oh, there's 4 of them left. Oh, well, that actually looks good. What's left over here if I take the 2? Oh, just a 3. If I multiply that, I get 6x. Well, I guess I'm going to move right along. Do the next problem. Remember, you're pausing the video. You give yourself some time to reconnect with what you already did. And if you do, you're making some nice pathways in the brain to be able to work a little bit more quickly and easily mathematically. That's what you're practicing. 3a squared minus 13a minus 10. Well, we talked about 3a and a. Boom, we got that one down. And then, because the factors of 10, 1, 2, 5, 10 could get tripled when they're in that slot. I don't think I want to do 10 times 3. No, but maybe I want to do 2 times 3 is 6, 6, 7, then that becomes, I should have said a 1, right? Right? I could do 3 and 10. Ooh, 3 and 10, but they got to be different signs. So what about 5? 5 times 3, 3. Oh, I like it. Bingo. Yeah. 5 times 3 gets me 15. Now it gets me minus 15 plus 2. Yep. So it's just trial and error. It's really a question of effort and checking what you're looking at, not just mindlessly throwing something on paper. All righty. There's your practice with that skill. All right. And if you have trouble with those, then, you know, later in the term, in another couple of weeks, we'll do 5 or 6 in a row. But if you can pick it up at this pace, then more learning is going to take place. Square root of 20. Well, square roots. 4, 9, 6. Oh, bingo. 4 fits in. So square root of 4, square root of 5. And I know that one of these can be renamed. And a lot of times people rename this one 5. Why? I have no idea. But it's 2 root 5. Right? And for all the years I've been teaching, I should know what the square root of 5 is, and I don't. I know the square root of 2 and square root of 3, and that served me well. All right, next. 2 root 10, but I'm gonna, well, I'll do it, put the original problem down. 2 root 2 minus root 5. There's that root 5 again. So I'm going to rearrange this to be 2. I'm going to bring this 2 out. Okay, that 2 is coming out. I'm going to rewrite square root of 10 as the square root of 5 times the square root of 2. And then this is still left. So you got to be careful that you keep track of things. There's some renaming here. And there's some renaming there. Root 2 times root 2 by definition gets you 2. Now, I asked you the other day, do you remember what the square root of 2 is as a decimal? And I'm guessing no, you know, because I've done this for how many years. And sometimes some students can't tell me at the end of the semester what the square root of 2 is. Be nice if you learned it. You're going to work with that number quite extensively in your high school career. Approximately 1.41. All right, square root of 2, approximately 1.41. All right, so we're getting close to being done with this problem. 2 times 2 is 4 times 2 is 8. So 8 root 5 is what you get when you multiply these two things. And now we're going to do minus, I got a 2 and a root 10, which I'm going to write as 2 root 5, because that's minus 2 root 10, and I'm going to multiply it times root 5, and I hope that you spot that. Again, that's 5. 5 times minus 2 is minus 10 root 2. And this is very much like saying 8x minus 10y. They're not like terms. You can't add them. If I had 8 root 5 and 7 root 5, well, that's another matter. That's 15 root 5s. I can count them. But they're the same. Can't do anything with that. Except throw it in the calculator and get a decimal approximation. Righty, what's next? Still working with square roots. Square root of 24. So I got to write the square roots. 4. Oh, bingo. Yeah, all right. So I already got a bingo. A 22 and B 21. All right. So we said that you can write this as 4 times 6 times A squared 11 times B 10 times B, and all of that is being square rooted. Then I know the square root of 4 expressed that way is 2. So I can take a 2 out of this. But the 6 is not easily simplified, so it's going to stay right there. And multiplication, right? Multiplication tells me that, I cut this in half, so I'm really just dividing by 2. That gets me 11, and dividing by 2 over here gets me 10, right? But I really want to do this properly, so dividing by 2, it's probably easier if I just write it. B to the 10, and 1B stays in. I think the numbers speak for themselves. All right. And there's nothing that says we can't make the same kind of process, think the same way with cubes. All right, so let's take a cube root, but instead of looking for multiples of 2, we're looking for exponents that are multiples of 3. 24. Is it? Oh no, different one. So cube root, a lot of people forget to put the 3 there for a while, and unfortunately that means it's wrong, because you'll be looking at a square root, not a cube root. Heat that coffee up in a minute. All right, so we're looking at 54. Let's see. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. But oh, bingo! Yeah, 27 fits inside that. I got a perfect cube here. Nice to know. A squared, B 15, C 17. Get these off. These are not helpful. So this is equal to the cube root of 27 times 2. A squared, not enough to take out of there, not enough to take out of there. C, B to the 15. Why don't I just start writing it again, the answer. So square root of 20, cube root of 27 is 3, but there's still 2 inside. Not enough to be able to simplify. B to the 15, 15 divided by 3 is 5. And 3 goes into 17, 5, with a remainder of 2. Okay, and that's a correct response. A little different linear function coming your way. Same process though. So we got 1973 was a very good year. Yep. Pi over 2. And we want 2023. 11 pi over 2. All right, so let's get our y equals. Let's get our x's taken care of. And 1973 to 23 is 50, jump of 50 years. And 1973, I want to translate into pi over 2, so that takes care of that. I don't think there's anything here that's been remotely difficult, except some new, characters to look at that we'll talk about in the future. Then the question is, how do you get from here to there? That's called displacement. How do you get from this place to that place? That was a little joke. Pi over 2 to 11 pi over 2. I think you're jumping by 10 pi over 2 plus pi over 2. Takes me to 11 pi over 2. You think about it, it makes sense. So what is 10 pi over 2? Pi. And you could reduce that to pi over 10. If you like to, you can. And that has significant meaning later in the course. All right. Well, that was that linear function. Now we want to get Vertex 5, 2. All right, so let's look at quadratic, fancy term for rectangular relationships. And there's a most important place. All right, y. Let's just square some numbers. 5 times 5, 25. -3 times -3, 9. +3 times +3, 9. You know, it looks to me like there's a trend here of positive numbers. Except when I make the square, the area smaller, I can get it down to 0. So 0 times 0 is what's important. That creates a minimum. And we have a minimum at 5, 2. So that 5 has to act like that 0. And that is why, geometrically, we're making this statement. And I want that 5 to translate into a 2. I got the marker. I just made it happen. What power? Power in the pen. Now, we want it to pass through a particular point. So we have to move to the right. We're moving to the right to the number, where the heck am I? 11. Well, that's a change of 6 units. And if I change that by 6 units and square it, I should go up 36 units. But how many did I go up? I went from 2 to 21. 2 to 21 is 19 units. So I actually got 1936. Well, that's a tough one to say. 1936. I did a better job that time. Of the process. A fractional amount of what should have happened. And that adjusts it accordingly. All right. So now we're looking at, God, 2, 7. This is a nice challenge question. I might let you just try it. And the only thing I'll say is, I don't want to see any negatives inside a square root at the moment. So see if you can get this on Desmos. It's a graphing feature on the internet. It's free. It's got great graphics. We'll be playing with that a little bit. You might want to check it out. But it allows you to look at 2, 7 to -1, 0. So I'm actually going to leave this on the board as a challenge and ask anybody in class tomorrow if they got it. If they're able to get this, and then we'll talk about it. All right. X1, Y1. Well, let's look at Y equals X. Y equals X, the identity function. You know, up here, 7 gets you 7, for instance. -5 gets you 5, -5. That's an identity, right? What happens when we slap an absolute value on it? We get a sign change. When this becomes negative, the absolute value says, give it a sign change, and you get this nice V-shaped graph. And it's got linear features. It's decreasing on the left, increasing on the right. We're going to put those graphs in piecewise functions later in the term. But right now, we're just looking at X1, Y1. And to get X1, Y1, X minus X1 plus Y1. That's what you've been doing. So when you use X1, it's got minimum again, right? Same thing with the quadratic. Minimum distance from 0 is 0. So you put X1 in, you've got that minimum. So here's X1, Y1. We'll say it's a V-shape up, doesn't have to be, but we'll call it that. And then when you put X2 in, we've created some number. I don't know what number we've created because I haven't given you any values. But whatever it is, I want to get Y2. And that's going to be Y2 minus Y1. And that should look pretty darn familiar from your pre-algebra classes. Oh, the heck you did that. Y2 minus Y1 over X2 minus X1. It's the easiest conversion to understand. The only difference here is we're adding an operation. All right, so that's what that was. All right, now we're at F. And here's another one. You tell me what you're looking at here. So tomorrow, explain to me why I put this with these letters. All right, so that's another challenge question. We'll talk about that tomorrow. But, you know, get me some points on the curve and then we'll have a little chat. All righty, and then we got a little binomial squaring. 2a minus 5 times 2a minus 5 has 4 parts to it. It's got the 4a squared part. It's got the minus 5 times 2. It's got the 10a part, minus 10a. It's got another minus 10a. And it's got minus 5 times minus 5, which is 25. All right, so 2a minus 5. Hope you can see these parts by writing it this way. Okay, I'm hoping that becomes effortless for you at some point. Okay, that's what that one was. So, and you can always check these with a number. So let's see. So we got 4a squared minus 20a plus 25. If this is true, then when I put a number in here, let's put 3 in here. 2 times 3 is 6, minus 5 is 1, and 1 times 1 is 1. So when I put a 3 in here, it should come out as a 1. 4 times 9 minus 20 times 3 plus 25. Well, 36 and 25 is 61. And 61 minus 60 is 1. It's just a quick check. You know, when you make a statement that you are saying 2a minus 5 squared equals this, just another way of saying that, it may be written that way or that way, it's the same calculation, then you might want to check it with a number every now and then. You're just entry level algebra, right? You got to get a feel for numbers, so you should be playing with numbers a lot and checking your what should we call it? Your considerations, your assessments. Let's see if I can get rid of some of this. These erasers aren't best. All right, there we go. Clean up that board a little bit. Where are we? Same kind of thing, I think. 15, so I'm 16, 4x to the 5th plus 9y squared, 4x5 plus 9y squared, and we're just going to write the answer here. 16x10 for 36 doubled is 72, x5y, and 9 times 9, 81y squared. All right, you're pausing the video, you're taking more time. All right, so exponential functions, trying to graph them, trying to make it easy. But like everything else, it's going to take you some time to get comfortable with things. 23, and I think I got a 1 here, maybe. Let's see. No, I don't remember 17. Yeah, there should be a 1 there. All right. All right, so exponential functions, growth or decay. Sure looks like it's growing, tripling. So something's tripling, boom, boom, right? Tripling, going up. But that growth is that part of the calculation. And there's something very important to understand, that this function is always bigger than 0. I mean, just check some of the 3 to the 0, 3 to the -1, 3 to the -2. 3 to the 0 is 1. That's 1/3. That's 1/9. Right? And that trend continues forever. And that trend is heading towards 0. Okay? So this thing can become very close to 0, but adding 1 means that the answers, the outputs of your calculation, are always bigger than 1. So we're going to put y equals 1 over here, and we're going to see it get bigger. Yeah. And so what numbers do we want to plug in? Well, it'd be nice to get 3 to the 0, and it would be nice to get 3 to the 1, because those are the easiest things to multiply by. So what makes a 0? 1888. Let's see, I better put it here because I got to triple that size. Right, whatever this is, and I know it's 10 units. Right, the next one has to be 30, and that way you get a fairly decent looking graph. All right, so we drop 1888 in, we do the math. 3 to the 0, what is 3 to the 0? 3 to the 0 is 1. Jump 10, which means that I'm at 1888. Very good year. Got a lot of friends back then. We've got a jump of 10 on top of 1, takes us to 11. And then we're going to be 30 plus 1, which is 31 if we pick the right number. And I think the number should change by 23. So we're going to add 23 units here. And that gets me a 1. Oops, I didn't, I'll put my X here. 1, 1 and 8, 9 and 2 is 11. So that's another 1. And 18, so 19. Oh, 1911. Yeah, that's a jump of 23 years. So in 1911, and you know, I had some friends back then. Got 31. All right. So when did we get 91? 91's up here somewhere. Ooh, that's going to be another stretch. Well, let's find out. Let's actually find out. Shouldn't have erased that. Repetition here means I'm going to have to write it again, I'm sure, but let's see. So we're looking at the inverse. The inverse is we're going to get some numbers, some answers to solving equations. How are we going to get those answers? Using inverse operations. So let's take our answers and do what? Subtract 1. Divide by 10. 3 to the becomes log base 3. Some of you are probably getting that now. Dividing by 23, multiplying by 23, and adding 1888. Okay, and now, instead of answers, we'll put the letter X. So we now have a function based on X that takes me from my answers back to the years. And I might as well graph that for you. Because if you can graph the exponential quickly, you can graph their inverse quickly. Takes more practice, and this is one that'll be harder for you to pick up. But folks who are well motivated, even 5th and 6th graders over in India, in a 3-week period of time, some of them 2 days, 3 days, really wanted it, really wanted to learn. So they put the time and effort in to see where everything went. So it's doable. So we're looking at the X's are important in the log, right? And there's a key X right here, and it's 1. And why do we need to say that? Because this parentheses has to be greater than 0. It's got to be bigger than 0. So our numbers, our inputs have to be bigger than 1. So what inputs do we want? Well, we know what log 3 of 1 is. It's 0. And that's a product. So making this 0 times that gets us 1888. So what makes this thing 1? 11. 11. So that becomes 0. That becomes 0. You get 1888. You know, I erased it before, but a minute ago, 1888 got us 11. And then we want to make this a 3. All right, because that's easy. Right, and multiplying by 1 is easy. So we're going to add 23 to 1888, which gets us 1911. Well, that's right. 1911 got us a nice easy number before. And so, well, where am I? Oh yeah, I'm trying to make this 3. So 10 times 3 is 30 plus 1 is 31. I hope you can see that that gets us this. And 1 times 23 is 23 plus 1911. So 31. And you're going to get something like that. I suggest you find another point on there because it's, well, maybe that's what we're doing here, setting it to 91. So let's do that. Let's set this thing to, oh, it's G of T to 91. All right. Well, we can put 91 in here now. We can put 91 in there because it's the answer to the equation G of T. So 91 minus 9 minus 1 is 90. 90 divided by 10 is 9. What do you put on top of 3 to get 9? A 2. 2 times 23, 46. So I'm adding 23 to 1911. And I'm going to be somewhere up here at 91. It's a big jump to climb, you know, another 23, which is 1934. Very good year. Had some friends back then. No. And so we're not graphing on graph paper or anything, but we're getting a feel for the trajectory, concave down shape. Righty. So now what's next? 16 to the 1/4. And that last problem, it was nice to have the inverse because then we could just evaluate the number 91. But here we are, 16 to the 1/4. Then the question is, do you recognize the language? That means the fourth root of 16, which happens to be 2. Now, 2 times 2 times 2 times 2 is 16. Hopefully you're getting some of these now that scared you last week that aren't so bad anymore. Nasty little critters. Log 81, log base 81 to get 27, to get 1 over 27. You know, you can do it conceptually, but if you have trouble conceptually, then you got to go to the well. All right. What's the number that ties these little critters together? 3. That's 3 to the 4. That's 81. To the x equals 3 to the negative 3. All right. That's 1 over 27. So therefore, 4 times x equals negative 3. And our answer is negative 3/4. So what's the fourth root of 81? 3. What's 3 to the negative 3? 1 over 27. So that's the exponent that gets the job done. Log 9 to get minus 81. I should have put this problem before what we did a few minutes ago. Okay, so on your test, you feel free to write that and go, boom. Can't use negative numbers here, right? Remember, there's no way. You try to get negative 81 out of this thing. Okay, and at some point, you're going to get tired of trying. All right, where are we now? Moving right along. Log 0.1. Well, it's not written. It's supposed to be base 10. 0.1, you can think of fractionally. And I hope you can see the exponent we're looking for is negative 1. Okay, there's the practice for that one. And we got 2a to the 5, b to the negative 3, all over 3a squared b. And that's to the negative 2. Again, I'm going to just simplify inside the parentheses, getting rather similar method each and every time. That's a to the 3. There's 3 more in the numerator. There's 4 more in the denominator. Now I'm going to flip it. So that's going to get me 3b to the 4 over 2a to the 3. But I still have to square it, which is going to get me 9a to the 8 over 4a b to the 8, excuse me, 9b to the 8 over 4a to the 6. All right, that one's done. Where am I on the sheet? What number was that? Oh, that was 31. Oh, we're getting there. This isn't so bad. All right, so 32 is up next. I should have been putting those numbers up in the left-hand corner. Make it a little easier to kind of flip through the video. So 32, we've got the function f. I wish I had gone timeline here, but that's okay. 9 1/3 t minus 1900 all over 123 plus 5. All right, I'm just going to do it quickly, but you take more time. So y equals 5. You got an exponential decay. First jump is 9 on the left and then 3. So I've got 9 on the left and then a third of that. So a third of that might be there. Okay, so that's going to give me my base 1900. Gets me this one, I believe. 1900 gets me 1/3 to the 0, which is 1 jump of 9 on top of 5, which takes me to 14. And then we want to change to 2023. 2023 here. And that's going to be 1/3 of 9. 3 on top of 5 is going to get me 8. But let's check it out. So that's 1, so 1/3 to the 1 is a third of 9 is 3 on top of 5, we're done. What's the inverse? Well, addition of 5 becomes subtraction of 5. Multiplication by 9, division by 9. Log base 1/3 times 123. That's division becomes multiplication. And then the last thing. Okay, and so these are the answers to a calculation, which means that when I drop these numbers in, it should bring me back to 2023. Let's see how that happens. 8 minus 5, 3. 3/9. 3/9 is 1/3. What do you put on top of a 1/3 to get a 1/3? 1. No, 2023. All right. Now, what else we got? That was the inverse. 3x minus 4y equals 8. Let me just get this from a different perspective. X equals 5. It's going to look like this. 1900 gets you 14, so 14 is the bigger number, so 8 is going to get you 2023. And this one here is, actually that's a 3-to-1 ratio horizontally. 14 is going to get you 1900. All right, so let's say, name that tune. All right, you're going to start seeing NTT all over your worksheet soon. So I'll be drawing these graphs and then asking you to give me the equation. So this was an inverse function from the previous problem. And what do I see? Well, I see Y values. I see 2023 from left to right. How do I get to 1900? I actually get down 123. This is a logarithm. What's the most important X value? 5. My numbers better be bigger than 5. Oh yeah, they are. These numbers work. Yeah, and when I drop an 8 in, I get a 3. If I divide 3 by 3, I get a 1. Log 1 is 0, so that gets me 2023. That gets me the asymptote. I'll drop a 14 in. 14 minus 5 is 9. 9 divided by 3 is 3. And what I think I'll do is I think I'll make that positive and make that a 1, because that reciprocates. Yep, that probably is a little sleight of hand that, yeah, you're probably wondering what the heck I just did. At the end of the semester, you'll know. All right, so I think we're just about done. We got one last problem. We have 3x minus 4y equals 8. 3x minus 4y equals haha. In other words, that constant doesn't matter. 3x equals 4y. So therefore, y is equal to 3/4 x. That's the rate of change. You give me $4, I'll give you back 3. I like that. Yeah, we could practice that. I think we did that every day for a couple of weeks. I think you'd understand rates of change pretty well. Yep. So 3 to 4 is the original slope. We want the perpendicular. So over 3 up over 4 up 3 looks like that. Perpendicular is going the other way. And so minus 4/3 x. What did I give you? Restive and enervate maybe? Minus enervate, weaken. That's, well, we're on weak right now. My arm's weak from all this writing of the enervation. Restive. Yeah. Well, there's that youngster again. Looks like he's impatient over there. A little restive, I guess. All right. We're done. And hopefully you're starting to put some of these skills in your pocket. We're just going to keep adding them. All right. Never going to stop this process. There's always going to be something you're working on until, you know, a month before the end of the term and put the brakes on completely. And no, I don't know. We'll see. All right. Nothing else? Nope. All right. Let's end this.